Hey guys, so today we are going to look at the last topic for this chapter. Yesterday we looked at how do I make more information in my equations, right? So today we are going to look at how do I interpret equations, how do I understand something from an equation that is given to me. There are a lot of things that can be covered here, but we'll only be talking about a few that are relatively understandable. Okay. If you want to know more, you can look at page number 28 of your reader. There's a lot of concepts that you might not know, so it's okay, just follow through with what we know here, and that is sufficient considering your exam point of view. Okay. So first thing is simple enough, states and formulae. Like how we mentioned yesterday, what physical state your reactants products are in, and how much what their formula might be, right? Like for example, NaNO3 or whatever the formula might be. Okay, that's the first obvious thing that we can know from any equation. The second thing is ratios. Now this is important. When we balance an equation, we learn how to balance. We notice we multiply each equation with certain each thing with a certain number, right? That tells us a ratio. To take a simple example, we looked at this reaction yesterday, right? How hydrogen and oxygen will give water. And to balance it, I did this. 2H2 plus O2 gives rise to 2H2. So 2 2s are 4, hydrogen 2 2s are 4, oxygen is 2, 2 1s are 2. So it is balanced. Now what this tells me is, if there are two atoms of hydrogen or two molecules of hydrogen, then they'll only meet with one molecule of oxygen to make two molecules of water. Okay, so I can call it as 2:1:2. Okay, this would be hydrogen, this would be oxygen, and this would be water. Okay, now that 2 can apply to anything. It can be molecules, it can be atoms, it can be moles, a lot. For now, simply just remember it as ratio of how much quantity is needed. Okay, finally relative mass. Okay, so when we have this ratio, we can understand relative mass. So related to how many atoms or what molecules are needed, can I relate it to a mass that I can understand, like kilograms, right, or grams? So molecules or atoms are very tiny, right? It's something that we have learned, and we can't really weigh them. It's not exactly something we can even see or weigh. So how do I convert that to a weight that I can understand? Okay, like kilograms or grams, which we can tangibly understand. So how do I change that is something we can understand from equations too. So to make it a little more clear, I have taken down this one problem from your reader. If it's not visible, it's on page 29 of your reader. It's about aluminum oxide and iron. So the question asks me how much aluminum is needed to get 1120 kilograms of iron when aluminum and iron oxide are reacting. So the first thing I need to do is figure out what is my reaction. Okay, my reaction is aluminum and iron oxide, right? Aluminum plus iron oxide. So when they react, I know the reaction gives me aluminum oxide plus iron, since I know the reaction. Okay, I'll quickly balance it on my own here. I know aluminum 1, 2, so I'll simply put it as 2 here. So 2 aluminum, 2 aluminum. Iron is 2, so this side it should become 2. Okay. So now the ratio over here has become 2:1 and 1:2, right? 2, 1, 1 and 2. Okay, so how this converts is, if you notice, there is some information given to me here. Aluminum equals to 27U. Okay, U is nothing but atomic mass unit. Okay, atomic mass unit, it tells me how much one atom of aluminum is going to weigh. So what I am going to do, I did not do it for everything over here. I need to only figure out for two major things, but let's see. Okay. I know aluminum is 27, but I have two aluminums here. So I'll write 2 into 27U. Okay. Plus Fe2O3. Now iron is 56, but 56 into 2. So 56 into 2 plus O into 3, 16 into 3. 16 is from O and 3 is from here. Okay. This is all in again U. Will give me Al2. So Al is again 27 into 2 plus O is 16 into 3. This is again in U plus 2 into Fe. 2 into iron is 56 U. Okay, so now 27 2s are 54U plus this is something 56 plus into 2 is 50, 100, 112 plus 48, which is nothing but 48, 50, 60, 160U. Okay, so 160U gives 54 plus 48, 50, 90, 98, 99, 100, 112U. Okay, plus 56 into 2, 112U. 40. I might be wrong here, just give it a check, but it doesn't really matter. Okay, just to know ki every atom I'm gonna make sure it's multiplied with its weight and its number and add them. Okay. Now in the question he asked me, find how much aluminum is needed to get iron. If I notice, aluminum is here, which means this one. To get iron, which is Fe, which is this one. Okay. Now I can simplify the equation by removing these two. I can say 54U of aluminum will give me 112U of iron. Simply put, through this reaction, okay, not a direct reaction. So I know 54U of aluminum gives 112U of iron. Now the neat thing about U is I can directly change it into grams. Okay, so that means I can directly say 54 grams of aluminum will give me 112 grams of iron. Cool. Now this is again a simple math problem. Crisscross, if you remember, it says we put something like this: 54G, this is aluminum, this is iron. Okay, 54 grams gives me 112 grams. But I need to find 1120 kilograms. Okay, so how much aluminum do I need to get 1120 kg? Right, so if you remember this method, how we crisscross, I can bring it like this. Okay, if I call this unknown as, let's say, x, so I can write 54 grams into 1120 kg will be equal to 112 grams into x. Okay. Now notice grams, kilograms and grams. Every sum, all the units should always be the same, right? So I am going to change this kilograms into grams. We know, right, that 1 kilogram is nothing but 1000 grams. So I am going to write it as 1120 into 1000 grams, which is equals to 112 G into X. Now I am going to bring this 112 grams on this side by cross multiplying, leave x over there. So 54 into 1120 into 1000 whole by 112, all of this is grams, is nothing but x. Okay, this grams is the unit. So right now I am going to remove the unit to make calculation easy. You can simply 112 tens are. Okay, now I simply have to multiply 540, 54 into 10, 540 into 1000 grams equals to x. Now 540 into 1000 grams, so that will become 540 kilos, right? Because 1 gram into 1000 will make, 1000 grams makes 1 kilo. So I can simply say this is 540 kilograms is x. So finally my answer is, to get 1120 kilogram of iron, for 1120 kg iron I need 540 kg of aluminum. Okay, Now I understand this is complicated, not something you have learned before. However, this is a higher order thinking question, so I encourage you to really go and try to understand this. There are other types of sums called STP and all, which are not really something that you need to learn right now. But from exam point of view, if you do try to learn this, it will be great. Otherwise, it's okay. Cool. So that's it for today. Thank you so much.